Okie dokie, and we meet once again. This is video number 8 of our Move Advanced Smart Contract Language tutorial. This video tutorial, we are continuing to work with vectors. We're going to write a module that is going to provide data feeds, in particular token price feeds. So if you don't know what a price feed is, a smart contract that provides on-chain token price. So I can call that module and I can obtain the token price from a particular token. And let's say we are going to be integrating this to a DeFi platform and we want to calculate a swap price. We can use on-chain data feeds to give us those values and do the math and do the calculation for a particular transaction. If you remember on vectors, we worked with a vector that was storing numeric values, but now it's different. We are going to have two vectors. The first vector is going to store strings, and the second vector is going to store the struct of the token price along with the timestamp, which means that when I update the module, I will be passing values outside of the blockchain off-chain onto the module for a particular token. So I need to obtain the source of that token price somewhere. Let's say you have an API that gives you those values, then we will go and inject those values onto the module. Those values must be stored in a struct along with the timestamp, because we want to know what was the last time we updated those price entries or those price feeds. I will have another vector called token feed. And what this is going to do is going to store, let me update this, token feed. It's going to store the last price and the timestamp. For every token that we add onto this module, we can add as many tokens. So let's say I want to store BTC, I want to store ETH, I want to store APT, I want to store any token. I will be passing the token symbol, and this will be a string value. So let's say I store BTC. So we're going to be passing BTC as a string value. That index will be used to then know at which index am I going to be obtaining the data for BTC. So the moment I inject a new token onto the data feed, I will be storing the token symbol, and I also will pass the token data, the last price and the timestamp, which means that under this token feed, I will have the token feed struct for BTC feed, for example. And this is just me to show you. This is just a name that I'm placing for BTC feed, but it's actually this struct for BTC. Then once we store the second token, we will have another struct also stored, or let's say ETH, or let's use APT feed, right? So we will have those details stored in the second vector. What I will have in the first vector is going to be the symbol. So let's say the second token is APT. This is a symbol. Then I know that at index 1, I can grab the values for that token, okay? And I can obtain and read those values. And we can use one of the functions, which is index of, to determine where is a particular symbol on the vector, obtain the index value, so that we can call token feed and read the data and pull the data out and read the token price. So let's go ahead and let's start. I'm going to go ahead and create a new file. This file is going to be called price feed. We initialize that module net to def addr, and we are going to call this price feeds. The first thing that I'm going to be importing from the standard library is going to be vector. We are going to work with strings, which means that I have to store that as well. So I'm going to be invoking the string module, and from there we are going to use type string and UTF-8. We are going to work with timestamp. It's a module in Move that allows me to obtain the system time on the blockchain, which means that I can grab the timestamp, the current timestamp from the blockchain, and store that locally. And this will be an unsigned integer 64. We will pass those values as unsigned integer 64. Use std, and you're going to see this on the next video. We will deploy this on the APTOS testnet, and we will interact with the module using the SDK. So that's coming. We're going to call this timestamp, and we'll use std, and we'll say signer, because absolutely we need to interact with the owner of the module and whoever is going to make calls to add tokens and update those token prices. We are going to build two structs. The first struct is going to store the token feed, which I already explained on the whiteboard, and the second struct is going to store both vectors. Let's go back to the whiteboard. It's going to store the string vector is going to store the token feed, which means that I will be referencing the token symbol and the token feed to this particular struct. So there's going to be one key struct that I'm going to be calling, so then I can update each individual token. Check this out. Struct token feed. This one has store, drop, and copy. Inside this struct, I am going to store last price. This will be the name of the property, and this will be type U64. And we are storing timestamp, and this will also be U64. That's going to be updated per token. Struct price feeds. And this has key because we have to reference with move2 to the signer. So the signer is going to be referenced to that key. It has store, drop, and copy. Now, as I mentioned, the first thing that I'm storing is going to be the symbol. So I'm going to say symbol. It's going to be a vector type storing string. The next item is going to be token feed, which will be the actual data. We type vector, the struct as a type. So we're going to use that struct type of token feed. We have our two structs built. Next thing that I'm going to do, I am going to make sure that the only account that can make changes or can update token prices will be the owner of this module, aka my module account, which means that I want to know that if anyone tries to use an account that is not the owner, throw me an error. Let's build that error code. This is going to be E not owner. Type U64 error 101. Next, we are going to initialize the storage because I have to initialize this module storage so then we can start updating and we can start adding data. When I deploy this module, there is a function that we can call as init module. And this name, ladies and gentlemen, if we define a function with init underscore module, this is the quote constructor function. The moment I deploy the module, it's going to run that function. And we only have to execute this function once, okay? I can define this to be init underscore module. This is not a custom name. This is a name that tells Move, this is the constructor function, which initializes storage, or it does any initial function execution. I'm going to be initializing the storage here, okay? And we have seen other videos where I initialize the storage with empty data. We initialize the storage and we reference that to the key, to the owner. Let's call this owner because this is going to be the signer that we're going to be passing. So we're going to call this signer. Now let's initialize the symbol vector. So we can say let symbols, this will be vector. We already know this, empty, and this will be type string. So that's how we create an empty vector for type strings. And now let's add the first token, which is going to be BTC. We are going to say vector push back. It's going to be the first item that we insert, and this will be mutable passing symbols, which is a struct. And now we are going to pass that string for BTC, for the symbol VTC. So we're going to say UTF-8, and this will be byte string, and we can call this BTC, okay? So this right here, ladies and gentlemen, inserts BTC as the first token in the symbol vector. Now I have to build this token feed, and I have to initialize that token feed with empty data. We're not going to pass real data because we cannot pass the token price when we initialize the module. This will be empty, then we will update on the other function. We're going to call this new feed, and now we have to define this type. It's going to be token feed because we want to follow that, and we just copy and paste because you know me, I want to go the easy route here. We're going to do this indentation here. Perfect. And now we are going to last price. We're going to say 0 and timestamp is going to be 0. Okay. But we will update this once we update the token price. So we initialize this empty data here, right, on this particular struct. So now I can use new feed to initialize the storage. The next thing I have to initialize is going to be this price feed. I am going to say let data feed. It's going to be equals to price feed. We want to follow the same thing. And now we are going to be passing those two properties, but we definitely want to now pass symbols. This will be the vector that we define, symbol. And under data, there's no way for me to initialize this empty because this has a custom type. This is going to be a struct type. I need to do it a little bit differently. I can still do the vector, but what I'm going to initialize instead of the type, it's going to be the actual vector itself. And inside the vector, we need to pass a token feed. We already did this one. This is the empty one. So we're going to go ahead and pass it here. So I want to say copy and throw it inside here. We will do this closure and we are good to go. All right. So we are effectively initializing this vector. This is brand new vector. This is the vector itself and passing the first token feed. that we just defined right here. And I'm going to close this expression. I have to also close this expression. And finally, we have to pass the data to storage. Move to. What's the first argument? It's going to be the key. And what's the key? The signer. We have to reference this to the owner. So we're going to say owner, which is initialized when we deploy the contract or the module. And what is the argument that I have to pass will be the data feed. This will be what we need to initialize. And that's it. That's the first function. Awesome. I'm just going to close this here. We're good. Next, if we do this, let's just test it out real quick. It's not going to show us anything, but at least we know that it's working. Okay, so we're going to say attribute test, and we're going to call this function test function. And now remember, this is a signer event. So I have to pass the signer. So we have to create this test account. We can say owner equals to, and we want to pass it to the module account, which means that I can do this. I can say at net to def. This is how we grab the address, pass it as owner. And now I can say owner, and this is going to be type signer. And now I can call init module and I can pass owner. That should do it. Let's see how that goes. Test. Let's give it a shot. And we have an issue. Oh, oops, I didn't pass the reference. So it has to be referenced to signer. So let's fix that. Okay, so I'm going to say signer here, and that should do it. Let's see how that goes. There we go. We have a pass, and sure enough, we're definitely seeing that we're triggering stuff that we are not using. But don't worry, we'll fix that. Let's build the next function, and I think this is going to be the most important function. This is the function that we are going to be updating the token prices. Okay, and we can add new tokens, and we can update existing tokens, etc. So let's call this update feed, and we are going to be passing owner, which is reference to signer. And now we have to pass two arguments. We have to pass the last price because we're going to be doing the off-chain to on-chain. We have to pass those values outside of the blockchain into the module. So I have to provide that value, last price. And this we know is U64. And we're going to be passing the symbol. So then we can now reference the symbol to the right index, and we pass the data and we store the data in the right location. So we can reference the symbol. So symbol, and this we type string. Now I have to acquire price fees because I am going to be borrow global. I am going to be moving from, so which means that I have to do that acquire. So I'm going to say right below here, so it doesn't cram, acquires. And what do I need to acquire? Price fees. All right. The first assert that I have to do is make sure that the only one that can make calls into this function is going to be the owner of the module. Okay, so we are going to say assert, bang, and now we have to determine that. I'm going to say let signer, and I'm just going to do ADDR, and I'm going to obtain the signer address so then I can compare that to the address of the module itself. Okay, so I can say now this is signer address underscore of, and I can pass owner. And this value should give me the address value, okay? Now here I can say signer address has to be equal to the module address, net to def, ADDR. If it's not equal, you are going to stop this, okay? And we want to throw that error code that we just declared here globally. We're going to say E not owner. So that's how we can confirm that only the owner of this module can make calls to update the tokens. So now the next thing is we are going to finally work with the timestamp. For timestamp, I have to first grab the current time on the blockchain. In the APTOS blockchain, this is how we do it. We say let, and we're going to call this time. And now I'm going to use from timestamp, we are going to get now seconds. So it's going to get me that timestamp on the blockchain. Now I have to read the data on the module. Then I can update the data and so on. So I have to borrow global mutable. So I'm going to say let data store. And now I have to grab that operation, borrow global mutable. Here we go. And we're going to say price feeds because we're going to be grabbing data that is already stored in that module under this struct, which entails both symbol and the actual token feed. Next, I have to pass the signer address. Okay, so I'm just going to take opportunity because I already have it declared here. Signer, ADDR, and that's it. So with this, I recorded the current time, and now I can manipulate that data. I can update the data. I have to create that same entry that we did here, but now with the real values that I'm going to be updating, right? So I'm just going to take opportunity of copying this. I'm going to use it right below here. I'm just going to leave it as is. And now we are going to pass last price right here. Last price and timestamp. It's going to be time, okay? Now with this, I can go ahead and update the token that I will be sending the values to. But I have to find where is that token located in the symbols vector. We need to find the index, which means that I'm going to be using that function that gets me the index and also the result, if it's true or false. If we find that that symbol that I'm going to be passing as argument to find index of is true, that means that I already stored that symbol, that token in the module. It already has data and we have to update that data. Else, if result is false, that means that this is a new token and we have to add a new entry on the module. So we have to push back and add this new token on the vector so that we can keep updating it. And this returns a tuple. So we are going to receive two values, the Boolean result of true or false and the index number or value. Okay, so we're going to say result and we are going to obtain the index value. Okay, and now I got to invoke that function vector index of, and I will be working with mutable data because we're going to be modifying the state of that struct. It's going to be mutable. Now I have to pass data store. Remember, we are borrowing the storage from the module. This should be located here. We are going to say data store, but then we want to find if the symbol is already stored or not, which means we need to find symbols. So we have to point to this vector so then we can do the index of on this particular vector. With that said, I'm going to say dot symbols. There you go. And now I have to provide the value that I want you to check if it's already in the struct or not, which will be the symbol that I will be passing as the argument. And this has to be passed as reference to symbol. Now with this, I should obtain either true or false, and then I should determine if I just need to update what's existing or add a new entry, okay? So let's do an if and else for this. If result is equals to true, then that means that the token is already in the module with probably an older last price value, which we need to update. I have to first remove the old entry. So I'm going to say vector remove. Again, we're working with a mutable state of what? Of data store, right? So I'm going to say copy data store. And now we have to invoke which vector. It's not going to be the symbol. It's going to be the data struct, which passes token feed. And then we can get to the last price and all that. From this particular vector, we want to remove the index that we obtain, right? Because if the symbol is already present on the vector, we should obtain that index value where that symbol has been stored on the vector. We pass the index, and this right here should remove whatever was stored before there, so then we can now update with the new entry. Okay, how do we update with the new entry? We are going to insert vector insert, and it's very similar. I'll grab all this, boom. The only difference is now I'm going to be passing that new data. What is the new data I'm going to be passing? This one that I just wrapped. The time that I'm obtaining from the blockchain and the last price that I passed. I'm going to say new feed. We're going to close this expression and that should be good. In case there is already a symbol, we are updating the values by removing the old ones and adding the new ones. Now, else, if it's not present on the vector, meaning that this is a brand new token that we're adding onto the vector or the module, I have to do an else. The else is even more straightforward. I have to push back to values. Remember, it's a brand new symbol, which means I have to do vector. I'm going to say push back, and I have to pass two arguments. I have to pass mutable data store for symbol. Remember, I'm adding that symbol on the struct symbols. I'm invoking that, and then I'm going to be passing what? Symbol. And then the next one is going to be the actual data, the last price, whatever, because we're not only adding a new token, but we are also updating the last price on that token. So we're now calling data. What do I need to pass? New feed, just the new values as well. There you go. This is how we update the existing token with the latest price and the latest timestamp, and how to add a brand new token and update its value as well. This is how we update the price feeds. We're not going to test this yet because I need to make sure that I can read it, okay? So let's go ahead and do that function and we'll test and we're done, okay? I am going to define function. Function is going to be called get token price. It's already auto-completed. And the only argument that I'm going to be passing externally, right? This is only internal because we're just doing testing, but this should be a public function. The only value that I will be passing as the argument is the symbol. All I need to know is the token price, which means that the only argument that I have to pass to the module is going to be the symbol. Like I want to know the price of APT, then I'll pass APT symbol. So I'm going to say symbol, and this will be type string. And what I want to return is going to be the token feed, because I want to return not only the token price, but also the timestamp. So I have to return the whole data struct, token feed. But remember, if we're borrowing values, we have to acquire. price feeds. And let's write the function. I have to obtain the vector, the symbol vector. So I'm going to say let symbols, let's obtain that vector, borrow global. This is not going to be mutable because we're not making changes here. And this will be price feeds. And now I am going to be passing the address, and I'm going to leave this as permanent because the only key in this module storage is going to be the owner of the smart contract. The only one that can make changes onto this module is going to be the owner, right? Which means that I will be passing something that is going to be permanent because this is the only key that references the storage for all my tokens. And because I did that, now I can say from borrow global, I could either grab everything and then just define separate symbols and data variables, or I can just say here for this symbols, right? And I can access that particular property inside the struct. Now let's obtain the index. We have to do something very similar because now instead of us updating, we have to find where that index is. So then we can now read the index. And we're going to say let, it's a very similar function. As a matter of fact, I'm going to copy this function right here, but now it's not going to be mutable. And this will be just symbols because this is what we define here. I'm going to say this symbols, reference to symbols, which is this one right here. And I will be passing symbol, which is the argument that I'm going to be passing externally. And now we should obtain either true or false and the index. If it's false, it's just going to not give you anything, but we have to also provide something in return. We're just going to provide zeros. Okay, we're just going to return zeros. So if result is equals to true, that means that I need to provide you the data. Let data feed, and now we got to obtain that. So we also have to borrow it. So let's go ahead and borrow. I'm going to copy this, borrow global. But now instead of passing symbols, it's going to be data. So this is going to be the second property. And now we're going to say vector. We are going to be borrowing those values. So this is why I am dereferencing vector so that I can drop those values and return those values to the user. I'm going to say borrow. And what am I going to be passing? Data feed. Okay, so we're passing data feed. And with borrow, all I have to tell is the index. So then it gives me the values from that particular index, which will be the last price and the timestamp. So I'm going to say index, copy, and pass it here. Boom, that's it. And I don't have to close the expression. This will be the return of token feed. But else we are returning what? An empty struct. Token feed. And we're just defining this to be empty. And I can just use this. There we go. So if there's data, it's going to give me the values back. If there's no data, it's just going to return this empty. And we're done. We're going to write that function to test it out, and we should be done. Now, because I will be invoking the timestamp, right? So I will be, quote, obtaining values from the blockchain, but this is a test. There's no such thing as a blockchain here. I have to initialize that fake timestamp by creating the timestamp account, which is basically the STD or the 0x1 account. Okay, this is the default account, the first account. ADR, I'm just going to call this init ADR, and this will be this one. Okay, this is the first account. And now I have to pass that as well. I'm going to say init ADR, and this will be signer. It doesn't have to be reference, okay? But now, because we are going to be reading token prices and adding token prices, it's going to acquire price feed, which means that this function must also acquire price feeds. So I have to also say it here in the test, right? And before I initialize the module, or I can do it after, it doesn't matter, I have to initialize that timestamp. I have to build a timestamp so then it can obtain the values from the timestamp. But it's fake. It's just going to return 0, by the way. Okay, so we are going to say timestamp. But on the next video, you are going to see this live on the blockchain, and you are going to see a real timestamp value. We are going to obtain from timestamp set time has started for testing. This allows us to test this. And we will pass the init address, which is the address that initializes the timestamp. This will be reference to init address. Now we initialize the module. The next thing that I got to do is I have to update the fee. Let's update a fee. So we are going to call update fee. That's the function that we define right here. You can see it right here. And it's expecting 3 arguments: the owner, the account, which should be my account, last price, and symbol. Let's provide that. So we are going to say update feed, and we are going to pass reference to owner, which we used right here. Let's say owner, and last price is the next one, right? Which will be a numeric value and then symbol. So let's pass the price of Bitcoin. I don't know what the price is, but let's just put a number here, 63,400. Okay, this will be the price of BTC. And I have to pass now the string value of BTC. So I have to pass UTF-8B, and then BTC, the symbol. With this, I should be able to update the values for BTC. Now let's do let result. And now we are going to call get token price. And the only argument that I have to pass is going to be the symbol, okay? BTC symbol. So let's just grab this right here, copy, paste it here, and we are going to print. I have to print the output. So let me go ahead and do that. Let me do test only, use std, debug, print, okay? I'm gonna say print, and we are passing reference to result. That should do it. Let's test it out and see how that goes. We should obtain those values. Boom, super clean, super clean. That's awesome. You can see it right here. We obtained back what? We obtained the last price, which is the value that we passed, and the timestamp, which means that we were able to read from the module. Let's do the following. Let's add a couple more. So I am going to now grab this. I'm going to add this right here, but then result is already initialized here. I'm just updating down here. But now let's add ETH, and we want to put ETH with 24 to 1. Let's grab the token price for ETH. And now after I do that, I will be updating once again BTC with 62411. We're going to say BTC, and we are going to grab it again, result. So you can see that we were able to update as we went, right? So it's able to update and get the latest result and then update it again and such. So we are going to now result, and this will be BTC. So we get back and we should be obtaining this new value. We should be obtaining the value of ETH, and that should be it, ladies and gentlemen. I'm going to copy this. That's it. Let's test it out and finish this video. Let's go ahead. This. Ooh, that is beautiful. What do we see? We see the first update, which will be the 63,400 for BTC. The next update was the ETH token. We passed this last price and timestamp. You're going to see zeros because this is just a test environment. And finally, we can see once again that the BTC price got updated, and now it returns 62,411, which was our last value. And we are done. Alrighty, this is the end of the video number 8. On video number 9, we are going to grab the module that we just wrote in this video number 8, and we are going to be deploying this in the APTOS testnet, and we will use the SDK to store the token prices and to read those token prices. It's go time. See you on the next video.